Cloud data center technology. As a developer, we ask for a machine so that we can put our applications on it. We may ask for 1, 2, 3, 10, 20, even 100 machines because we want to serve our customers. But have we ever thought about how are these machines installed? How are they configured? What happens in the data center? So in this section, we'll look at the various aspects of a cloud data center. So what are the objectives? We look at the makeup of a data center. We look at the data center design standard. Believe it or not, there is actually a standard for data center designs. We look at what servers are and how racks are organized within a data center. And then we'll look at cabling. We'll also look at networking, which is an important aspect of data center because you're connecting all these different infrastructure hardware together. You need to have good networking. Then we'll also look at cooling, which is another very important aspect of a data center. All these different hardware that's running generate a lot of heat. And so you need cooling. You, of course, need power for cooling and to power up the machines. Then we look at containerized or modular data center, which are some modernized data center technologies. Then we look at several tiers of data centers. And then support staff, which is another very important aspect of data center management. Data center. A data center is actually a special facility to house and manage your computing resources that are critical to the organization. So as you can see, racks of servers, there are specialized rooms for operations and management, there are heating rooms, there are telecommunications, so there's a lot of stuff that makes up a data center. So what makes up a data center? Well, data center is really a special building structure. Just like in a house, you have the family room, the living room, the dining room, the kitchen, the bathroom. In the same way, there are different kinds of rooms. In these different rooms, there are different kinds of equipments that are placed. So let's look at that. There are power backup structures. So we have these power backup systems. There are cooling systems. The cooling systems need to keep the server rooms cool. Otherwise, things can break in the servers. Servers can start failing. There are also some special purpose rooms for management and support. There are equipment cabinets. As you can see, there are these cabinets. That's where the servers will be placed. There are structured cabling that's going on behind so that all these different servers are connected. There are network devices like routers, switches. There is also storage systems, which are your storage servers for your data disk systems. And then there are also servers, which are your actual physical servers. And then security is another important aspect, is physical security. There's also monitoring centers. There are special rooms where people sit down and monitor the entire data center. And then there are miscellaneous other support systems. And the most important thing is there is software. There's a very important piece of software called virtualization software, which we're also going to talk about in this module. So let's look at the evolution of a data center. The data center has evolved tremendously in the last 6 decades. Initially in the 1960s, when it started, data centers used to have mainframe systems. Each mainframe server would be the size of a typical room, maybe a 15 by 20 feet servers. There were many of these servers in a data center, and every company had its own way of organizing a data center. There was really no special data center standards. And then over time, in the 1980s, we started seeing the evolution of low-end servers, and so we started seeing lots of low-end servers or commodity servers coming into play, and lots of companies started using these commodity servers within their data center, to the extent that we started seeing those blade servers where you can have a rack, and a rack can have several blade servers, which we call the 1U server or 1-unit server. Right? So we have many of those servers. And then with Moore's law, which basically says that every 18 months, the capacity of a hardware doubles. Basically what that means is the computing capacity and the storage capacity and the RAM capacity of these low-end servers started becoming so good that we started using a technology called virtualization, which is really the idea that you can have one physical server and you can have many logical servers or virtual machines on top of that. So we started moving towards what is called the virtualization of data centers, which is the foundation for cloud computing. We'll talk more about virtualization in the next section, But for now, let's understand how the data center has evolved, starting from the 60s as mainframe servers to commodity servers to virtualized servers at this particular point. Believe it or not, there is actually a data center design standard. It used to be that there were no standards initially, but the Telecommunications Industry Association, which is called TIA, published the first standard in 2005, which became a big hit. And so many organizations are now following the TIA-942 standard for data centers. You can, if you want, you can go to TIA-942.org and take a look at the data center design standards. But let me cover some of the important aspects of the data center as part of this section. This standard covers the site, space, and layout, how the data center should be laid out, how the cabling should be done, and also talks about several tiers of data center. All data centers are not created equal. You have tier 1, tier 2, tier 3, and tier 4 data centers, each with its own SLA, so it talks about that. And then it also talks about the environmental considerations of a data center. Don't forget, data center houses IT equipments. IT equipments generate heat, so they need to be cooled. That leads to global warming. So there's a lot of stuff that is related to environmental considerations. And also, there is also the environmental consideration for the perspective that you need to make sure that if there is flood, that your systems are going to survive. When there's a disaster, fire disaster, your systems are going to survive. And the disaster recovery mechanism and things like that. So there's a lot to it when it comes to environmental considerations. Here's the TIA 942 compliant data center showing key functional areas within a data center. This is more for architects and designers who are actually building data centers, but you can see how it generally looks. There is something called the entrance room. In the entrance room is where the carrier telecommunications equipment is placed. This is where your telco lines are coming in. There are also offices and operation support rooms. There's also a telecom room where you have some other office operations that are going on. And then this is your main computer room. This is where your servers are placed. And that's also organized as the main distribution area, which is where the switches are. And then there is something called the host distribution area, which is where the LANs are. So there are several LANs that are connected. And then there is the racks and cabinets. So the point I'm trying to make here is that in a data center, you may have 10,000 servers. It's not that all the 10,000 servers are connected together into one switch, into one network. They're all broken down. In fact, they are broken down into multiple local area networks, which are then connected into the main distribution area. So there are 2 or 3 levels of networks that are going on. It's a hierarchical network design. That's what I need you to understand in this particular slide. Okay, let's talk about servers and racks. So when you have a data center, you want to have lots of servers, and typically these servers are 1U or 2U servers. As you can see here, I have a server rack. This particular server rack has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 servers. You could have 10 servers with one switch on it. But anyway, in this particular case, you have 11 servers. Typically, a server rack contains about 20 to 30 servers, and you can have many of these server racks, and then they could all be connected. So that's really the idea of the servers and racks. Okay, so now let's talk about cabling. This is an example of bad cabling. You have no idea from which switch to which computer the cables are going. You have these colored cabling going on. I mean, I'm sure there is some kind of a method to this madness here, but it's pretty messy. This is an example of bad cabling. You don't want to be doing this. This is what we call unstructured cabling. Cabling really should look something like this. Look at this. It's really beautiful here. It's structured cabling. It's all nicely organized. And I'll show you a video in the next section where you'll see how cabling is done and how good cabling is done. Okay. Now let's talk about data center networking. Before we talk about data center networking, I should talk about 2 different devices that are network devices, and they are switches and routers. Switches are used to connect computers to create local area networks. So like I said, in a data center, you would take about maybe 20, 30, or 100 servers and connect a local area network. And those computers are connected using switches. A switch is really a layer 2 device. If you recall, there are 7 layers of OSI in terms of networking. Layer 1 is the physical layer, and layer 2 is the next layer above that. It's a logical layer, which deals with the Ethernet protocol. Switches actually operate at the Ethernet protocol. It keeps track of the servers and computers using MAC addresses. Every computer has a network card. The network card has a MAC address, and the switches track every computer using MAC addresses, and so it actually speaks the Ethernet protocol. All the communication is happening over Ethernet. And so it serves as a controller for servers to communicate efficiently. So if you have one computer or one server that wants to talk to another server within the same local area network, it'll go through the switch, and the switch will forward it to the appropriate server. Now, I don't want to get into the details of data center networking in terms of how switches work. You can take a class on networking where you'll learn more about switches and routers and other kinds of networking devices. All I want you to understand at this particular point is that switches operate on layer 2 and they communicate with each other using Ethernet protocol. Then you have routers. Routers are used to connect networks. So you have a bunch of networks and you need to connect these networks together, and that's where the routers come in. Routers are layer 3 devices, so they operate on layer 3, which means they operate at the IP layer. So now they are actually talking the layer 3 protocol, which is the IP protocol. And the routers are typically used to connect computers to the internet. You may have routers within the data center, but then you also have one router or a couple of routers that'll connect you to the internet itself. So that's switches and routers. As I mentioned to you, the networking within a data center is a hierarchical network. It's not a flat network. We have what is called the core, aggregation, and access switches. There are 3 levels of switches that's there. Here you're seeing the data center right here. That's the perimeter of the data center. As you can see, you have routers. Routers are the ones that connect you onto the internet. And then within the data center itself, you have 3 levels. There's switches, which is the core switches. There is the aggregation switches, and then there's the access switches. What you're seeing over here are racks, and these racks have servers. So you're connecting these different servers to create your local area networks. And then these local area networks are further connected into what we call the aggregation networks, which are then further connected into these core networks. Now, once again, I'm not going to get into the details of network design. There are entire courses at Johns Hopkins University that you can take that talks about how networks are designed. At this point, all I want you to understand is that the best practice is typically to create a hierarchical network. Although, as a cloud user, we will be creating our own logical hierarchy based upon software, but physically, this is how things are organized. So we talked about these switches, core switches, aggregation switches, and access switches. The switch that's closest to the server is what we call the access switch. Let's go back and look at that. As you can see, here are your access switches, and these are your servers, and they're connected to the access switch. Let's see how that's done. There are 2 styles of access switches. There is the top of rack access switch or the end of rack access switch. In the top of rack access switch, you have a bunch of servers within a rack. So this is a rack, and a bunch of servers within a rack that are connected to a switch that is all the way on the top. That's why it's called the top of rack switch. Top of rack. Switches are placed on top of the rack, and then all these switches are then connected. So that's the top of rack switch. Then there is also another kind of switch where rather than having a switch at every rack, you end up having switches at the end of the row. So as you can see, at the end of the row, there is a rack that contains only switches. And there are advantages and disadvantages of using top of rack versus end of row switches. Again, you can learn more about this in a networking class, but what I want you to understand is that in a data center, these different models exist, and the data center designers actually look at these different options. For example, if you use the end of row switch, you have to run a longer cable to the switch, right? So that's one of the disadvantages of that. All right, so let's continue on. We know that these servers, which are computing equipments, generate heat. If you actually sit down with a laptop on your lap, you can see that once you start doing your programming and once it starts working, your lap actually starts becoming warm because the computer generates heat. And if you actually look at inside of a computer, there's actually a fan. You probably often have heard the fan turn on. Now think about a data center that contains hundreds or thousands of servers. That is going to generate a lot of heat. And if it becomes too hot, the equipment starts failing. So what you really need is some kind of a cooling mechanism. And so pretty much every data center has what is called a mechanical room. A mechanical room houses mechanical equipment such as the air conditioning systems and the cooling engines. Here you're seeing a picture from the Google data center. You can see these different cooling lines that are running through. They're nicely painted with the colors of Google. This is a picture that I got from the internet. And by the way, in the next section, I'm going to show you some videos of real data centers where you can see these cooling equipments run. Right, so let's look at cabinet and rack arrangement. What I'm showing you is a data center, and you're looking at 3 rows of servers. You have row 1, row 2, and row 3. Imagine going deeper, racks of servers. Again, racks of servers and racks of servers. So what this means is these are aisles. So that's an aisle, that's an aisle, and that's an aisle, and there's also an aisle over here. This is the floor of the data center. You can see that it's a raised floor. That's because we'll be sending cooling from the bottom of the floor. And you can see this concept of blue arrows and red arrows. Blue arrows are cold air coming from the bottom, and the red arrows are hot air rising to the top. The way the data center is organized, the way the servers are organized, is that a single row here has servers placed. Now this is where the servers are placed. This is where the front of the server is. Notice the front of the server is right here. In the same way, we have another row, and then the front of server is right here. And notice that the front of this server is facing the front of this server, right? So the front and front are facing together. They don't generate heat. This particular section doesn't generate that much heat. These are all fronts of the servers. It's the back of the server that generates a lot of heat. So what they do is that they keep the fronts together, and then they keep the backs facing each other. So in this particular case, you see the rear of this server. That's the front of the server. This is the rear. And then you have to see the rear over here. Now these are the ones that are generating heat. So we call this the hot aisles. This is your hot aisle. And that's your cold aisle. Oops, can't write well here. That's your cold aisle. So as you can see, we have cold aisle and hot aisle, cold aisle and hot aisle, and so on and so forth. Whenever the rears of the servers look at each other, it's the hot aisle. Whenever the fronts of the servers look at each other, it's the cold aisle. And there are perforated floors on the cold aisles that'll blow cold air up. And that cold air is then sucked into the other side, and then the hot air rises to the top. And there is this entire air conditioning system that works on. So the point I'm trying to make is there is this method to this madness of arranging servers within a rack and racks within a data center. What you're seeing over here is a row. In this case, because I'm seeing the backs of servers, with the backs of servers over here, I'm assuming that this is a hot aisle. This is a hot aisle. Here's a thermal image of a cold aisle. So I have an image over here, and then I have another image over here. Same picture, except one is a thermal image. This is actually perforated floors over here, which leads me to believe that it's cold aisle. And as you can see, the thermal image indicates that it's pretty cool at the bottom and it's pretty hot at the top, right? As you can see, as you go up, it's getting hotter. That's the thermal image of a cold aisle. There is something called power usage effectiveness. It's also referred to as PUE, power usage effectiveness. And that's really how energy efficient is a data center. It is actually measured as PUE. So people often ask, what is your PUE? And the way it's calculated is the total data center facility power that is in the data center divided by the power used by the IT equipment. Think about it. The only power you technically need is the amount of power that is needed to run the IT equipment. All the other power requirements are just to support it. So what you do is you take the total power, you divide it by the IT power. You'll notice that this is always going to be larger, right? The numerator is always going to be larger than the denominator. And the idea is that you want that number to be as close to 1. An average data center has a PUE of 2.0. In other words, 50% is being utilized for cooling and 50% for the servers. But a highly efficient data center may have a PUE of 1.2. And you really want to get that number as close to 1. So a data center's power usage effectiveness is measured in what we call PUE. A number close to 1 is the best number. There are also these things called the container-based data centers. Data centers have been changing over time. Rather than buying servers and placing servers on the rack, you end up buying racks. And then now you end up buying these prefab data centers. These data centers look like shipping containers. And these shipping containers contain everything that's necessary to run a small data center. So it's got the power equipment, it's got the cooling equipment, it's got the servers, it's got the routers, it's got the telecommunications, everything you need. All you do is just power it in and you supply all the different power that's needed for that. That's what we call the container-based modular data centers. Almost all the companies are moving towards this kind of a data center. Amazon's Perdix right here, Microsoft's ITPAC, and there are also other companies that are making these different containerized data centers. So this is becoming pretty important. I'll show you a video in the next section where you can see some companies advertising containerized data centers. These container-based data centers are ready to use. You connect to water and power supply and then you go. Built-in cooling, connect to water and power supply and go. Easy to scale. You can put data centers in trailer parks if you want. It doesn't really even have to be inside a physical room. And it's suitable for disaster recovery, flood, earthquake. If you want, you can just pick up and move, right? So it's pretty cool technology that people have developed over time. In terms of data center tiered availability, there are actually 4 tiers of data centers. So whenever they say that I have a data center, you have to ask them, what tier is it? Is it tier 1, tier 2, tier 3, tier 4? Because each tier actually has a certain availability. Tier 1 data centers are 99.671% available, which means they'll have an annual downtime of 28.8 hours. Compared to tier 2, which can have a downtime of 22 hours and 99.741% availability. Tier 3 is 99.982% availability with 1.6 hours of downtime. Tier 4 data center, which is 99.995% availability with only 0.4 hours of downtime. As you can see, Tier 4 data centers are highly optimized, highly available data centers. They have multiple power supplies coming into the data center, multiple telecommunications equipments coming into the data center, multiple lines that are running through these different servers, both in terms of power, networking, switching, and everything. So it's highly available, fault-tolerant data centers or Tier 4 data centers. And nothing is possible without a support staff. And as you can see over here, there is the support staff that is in a data center that is continuously monitoring the data center. There are also folks that are going in and fixing servers. There's also physical security, which is another important aspect of a data center. Here's another administrator debugging some kind of an issue with the data center equipment. So the support staff is extremely important in a data center. In summary, we learned that TIA 942 is a standard for data center design, which did not exist until 2005. Now most companies are following these data center design standards. In a data center, servers are arranged in racks, and racks are connected to create rows. These servers are connected through structured cabling rather than unstructured cabling. There is also hierarchical network design. Rather than connecting all the servers into one single switch or router, they're all connected in a hierarchical fashion. There's also these servers that generate heat, so you need cooling. Power is needed for servers and of course for cooling also. Future is greener and modularized data centers. We saw an example of a modularized data center or container-based data center or containerized data center. There are 4 tiers of data center based upon availability, and tier 4 is the highest available data center. Several kinds of support staff are needed, all the way from monitoring to supporting the servers, the hardware, supporting the HVAC equipments, which is your cooling equipments, and of course security. Physical security is important to make sure that your data center is safe and no data loss takes place.